All right, you guys. I'm going to try to simplify this, and my iPad is having some storage issues, so I will try to show you a problem, get through this effective annual interest rate, and set up the formulas and show you how it's done. Basically, effective annual interest rate, if you read this all the way through, it's saying how do we turn an interest rate that is compounded a certain number of times a year and an interest rate that is compounded yearly, how do we represent that as simple interest rate? How do we represent that as an interest rate that is only given to us once a year or once during a given time period? Well, in order to do that, the first thing we have to do is we have to kind of separate out the interest rate. We're not really concerned with the principal here, and we're not really concerned with the time. So if I was going to separate the principal would be that initial portion, right? And that would be multiplied by the ratio that we get when we do 1 over your rate, 1 plus your rate over the number of times compounded. And then I'm going to put a separate set of parentheses around this and put my t out here. So this would be the amount that we start with. I'll say that is A. This will be the amount of t. And this is going to be the B. That's going to be our ratio. All right, so our ratio is what we're worried about right there. And our interest rate will be found within this ratio. As another example, we've got the compounded continuously. We're going to pull out our principal. We'll call that our A, our starting amount. We're going to come over here. We're going to write our ratio, which is just e to the r, right? That's our b. That's how things change every, and I'll put parentheses around, so put our t out there, every time period. And it's only the b portion we're worried about. So if I wanted to get an effective interest rate using this formula, the only one I'm going to pull out is the interest rate. 1 plus r over n to the n power. And over here, the only one I'm going to pull out is my b, my interest rate, which is e to the rate. Now, if you remember, this is going to give us an answer like 1.03% or 1.07%. And all we really want is the growth rate. So we don't want the full ratio. So if I had 1.05, that would be my ratio of 105%. What I really want is the growth rate, that last 5. So what I want to do is I want to subtract 1 from it once I get this. Same thing over here. I'm going to get a simple interest rate, but it's going to be our ratio. It's going to be over 100% most of the time. So we're going to subtract the 1, and that's going to leave our growth rate. Or if we have a 90%, it's going to leave our rate of decay. Now, most of these examples down here are going to have a growth rate. So if I look at this account X, and I'll just write account X, and we'll plug it into the formula we have up here of compound interest. So X says it's compounded, so we're going to use that formula. We're going to have 1 plus our ratio, which is 0.025. And then this one looks like it's compounded quarterly. So we're going to divide it by 4 and also take it to the 4th power. When we're done with this, we're going to subtract the 1 back out of it. So we're going to say minus 1. And if you plug that in your calculator, you should get approximately 0.02524. I think the Y fits on there as well. So let's go ahead and do this, my view on screen. And we're going to do the same thing. We're going to do 1 plus, except this time, the interest rate is a little smaller, so it's 0.248. But now it compounds more awfully. Instead of 4 times a year, this is monthly, so 12 times a year. So we're going to do the 12th power, and once again, we're going to subtract 1. And this one's going to be approximately, well, we'll say 0.02508. And we can see that they both come off very close to each other. Even though this one is compounded less often, it does have a higher starting percentage rate, and both of these end up being over 25 or 2.5%. This is 2.524, this is 2.508, and that's these compounded or compound interest rate expressed as a simple interest rate. I'm going to set one more up, and let us find one on here that has Well, there's one right there. It's compounded continuously. So account A right here, and I'm going to end up after this. I'm going to stop because I want to make sure the video is small enough to post online, and my iPad doesn't have much storage. So if we look at this one, this formula, since it's compounded continuously, is going to be E to the rate, which is 0.0324, and then once again, that's going to give it the whole ratio. We only want the rate of growth, so we're going to subtract 1 off of that. All right, and if you were to plug this into your calculator, you're going to get approximately, squiggly line, approximately 0.03, I don't know, 293, somewhere around there. Anyway, I promised you guys I'd throw a video on. Sorry about the late upload, but I'm going to get it up here this morning, and I will see you guys on Tuesday.